Section 4.2, Solving Systems by Substitution. Question 1, solve the system using the substitution method. And they give you the two linear equations for the system. Okay, to do it by substitution method, this is what y equals. Y equals negative 5x plus 17. Here in this first equation, you're going to substitute what y is. So instead of writing x plus 5y, I'm going to write x plus 5 and then negative 5x plus 17 equals 13. Again, I've substituted what y is into the first equation. Okay, now this becomes something that we did back in, for exam 1. Solve for x. First thing I need to do is distribute. So I have x minus 25x plus 5 times 17 is 85 equals 13. Next, I want to subtract 85 from both sides. So x minus 25x, which is negative 24x, will equal 13 minus 85, which is negative 72. I did two things in that step. The x minus 25x, that's really 1x minus 25x. So 1 minus 25 was negative 24. So that's where that negative 24x came from. Okay, next thing is to divide both sides by negative 24. So x equals negative 72 divided by negative 24. Negative 72 divided by negative 24 is 3. So x is 3. I'm only halfway there. I have the x value. Now I need to get the y value for the solution. So I'm going to go plug that x into this equation to solve for y. Y equals negative 5 times 3 plus 17. Negative 5 times 3 plus 17 is 2. So my solution set is 3, 2. Question 2. They give you the system. They solve for x equals on the second equation. So I'm going to plug what that x is equal to into the first equation. I'm substituting for x. So I have 4 times x, which is 4y plus 5, equal to negative 3y plus 1. When I distribute the 4 on the left, 4 times 4y is 16y plus 20 equals negative 3y plus 1. I'm going to add 3y to both sides. So I get 19y plus 20 equals 1. Subtracting 20 from both sides leaves me with 19y equals negative 19. Dividing both sides by 19 leaves me with y equals negative 1. That's my y value, negative 1. To get my x value, I'm going to plug this y into, you can plug it into either one, but I'm going to plug it into that second one. X equals 4 times negative 1 plus 5. 4 times negative 1 plus 5 is 1. My x value is 1. My y value is negative 1. This system has one solution. Number 3, they give you the system, but they don't give you either one of them in terms of, like y equals something or x equals something. But this equation, if I subtract 6x from both sides, would leave me with y equals negative 6x plus 6. I like that. I'm going to plug this y into this equation. So here we go. 3x minus 5y, but I'm not going to write y. I'm going to write negative 6x plus 6. So 3x minus 5y equals negative 19. Now let's go solve for y. First, I need to distribute. 3x, negative 5 times negative 6x is plus 30x. Negative 5 times 6 is going to be negative 30 equals negative 19. Combining my x's, 3x plus 30x gives me 33x minus 30 equals negative 19. I need to add 30 to both sides. 33x equals negative 19 plus 30 is 11. Now dividing both sides by 33, I get x equals 11 over 33, which will simplify to 1/3. My x value is 1/3. Now for my y value, I'm going to plug this x. I can plug it into either one of the equations. I'm going to plug it into that equation. So y equals negative 6 times x, which is 1/3, plus 6. Negative 6 times 1/3 plus 6 is 4. So my solution, my one solution to the system, is the coordinate 1/3, 4. Question 4, solve the system. Okay, this one isolates the x. It tells me x is negative 8. I'm going to go plug that in to that equation, to the first equation. So I get negative 4 times x, which is negative 8, plus 2y equal to 12. Negative 4 times negative 8 is 32, plus 2y equals 12. Subtracting 32 from both sides, 2y is equal to 12 minus 32, which is negative 20. Dividing both sides by 2, y equals negative 20 divided by 2, which is negative 10. Y equals negative 10. Now, we don't have to solve for x because we already have it. X is always negative 8. So my solution is negative 8, negative 10. My one solution is negative 8, negative 10. Question 5, solve the system using substitution. Okay, I'm going to solve for y equals on the second equation. To do that, I need to add 3/2 x to both sides. So I would get y equals 3/2 x minus 1. All right, so I have those two equations. I'm going to plug this y into the first equation. So 3x minus 2y, what is y? It's 3/2 x minus 1, and that equals negative 2. Okay, distributing that 2. 3x. Okay, negative 2 times 3 halves is negative 3. So I get minus 3x plus 2 equals negative 2. Combining like terms, 3x minus 3x is 0x. In other words, 0. So that's gone. I get 2 equals negative 2. That is not a true statement. Not true, which means there is no solution to the system. How did we get no solution? That was when we had, what were they, parallel lines? Remember? So no solution. Where is that? The system has no solution. The lines are parallel, but we have an inconsistent system. Number 6, solve the system using the substitution method. Okay, I'm going to solve, let's solve the first equation for x. So if I start with 2x minus 4y equals 8, I need to add 4y to both sides. So 2x equals 4y plus 8. Then I need to divide by 2. So I get x equals 2y plus 4. That's what x is. I'm going to get rid of this equation. Okay, I'm going to plug that in to the second equation for x. Again, I'm plugging this x value, all of this stuff, in wherever there's an x on that second equation. So negative 6 times 2y plus 4 plus 12y equals negative 24. Distributing the negative 6, I get negative 12y minus 24 plus 12y equals negative 24. Combining like terms, negative 12y plus 12y is 0y. So those are gone. And I get negative 24 equals negative 24. That is a true statement. Now, let's go back up here and look at the one before it. We ended up with some kind of a false statement. This was not true, so there was no solution. When we end up with a true statement, like negative 24 equals negative 24, that means there are infinitely many solutions. How did we get that with graphically? The lines had to coincide. They had to be on top of each other. There's the red line, there's the blue line. There are infinitely many solutions to this system. So infinitely many solutions. The solution set would be, you can put either one of those equations or this one. I'm just going to type down that first equation. What is that? 2x minus 4y equals 8. And the equations are dependent. Infinitely many because the equations are dependent. Question 7. It already gives me y equals 5x minus 14. Let's go plug that in for that y. So I'm plugging this wherever it says y in the first equation. So 5x minus 14 equals negative 1/2 x minus 3. I'm going to add 14 to both sides. 5x equals negative 1/2 x. Negative 3 plus 14 is 11. So plus 11. Now I want to add 1/2 to both sides, 1/2 x. 5x plus 1/2 x, 5 plus 1/2 is, as a fraction, 11/2. So 11/2 x equals 11. I want to multiply both sides by 2. 11x equals 11 times 2, which is 22. Divide by 11. X equals 22 divided by 11, which is 2. I know x equals 2. I'm going to plug that x value into either one of these equations. I'm going to choose to plug it into the second equation. Okay, y equals 5 times 2 minus 14. 5 times 2 minus 14 is negative 4. I have one solution, and it is the point 2 comma negative 4. I'm going to show you with this one that if you plug this into the first equation, y equals negative 1/2 times 2 minus 3. Negative 1/2 times 2 minus 3 is also negative 4. That's why I tell you you can plug it into either equation. Question 8. Just because it has decimals in the system, don't panic. We're going to do the same thing. Y equals, okay, it already has y equals. We're going to plug that in wherever y is in the second equation. So 0.25x minus our y, which is 0.25x plus 4, and that's supposed to equal negative 4. I need to distribute this negative out front to get rid of the parentheses. 0.25x minus 0.25x minus 4 equals negative 4. Combining like terms, 0.25x minus 0.25x is 0x. Those are gone. I'm left with negative 4 equals negative 4. That is true. So there are infinitely many solutions. These equations are dependent. They're the same equation. So there are infinitely many solutions. The equations are dependent. And let's go write one of the equations in this blank. Let's see. Y equals 0.25x plus 4. Again, I'm not real sure what they want in this blank because I'm not actually in Connect Math, but you should be able to put either equation there. Last question, number 9. Set up a system of linear equations and solve for the indicated quantities. Two positive numbers have a difference of 31. The larger number is 4 less than 6 times the smaller number. Find the numbers. Okay, to start with, you have two numbers, x and y. Let's let y be the bigger number. So y is the bigger number. Two positive numbers have a difference of 31. Since the difference is a positive number, you need to do the big one minus the small one. Big minus small is 31. Okay, for our second equation, the larger number is, so that's an equal, 4 less than 6 times the smaller. So the larger number is 4 less than, so I'm going to subtract 4, 6 times the smaller, 6 times the smaller. Y equals 6x minus 4. Okay, I have y equals on the second equation. I'm going to plug this in wherever I see a y on the first equation. So here goes. Y, 6x minus 4, there's y, minus x equals 31. Y minus x equals 31. I don't need those parentheses because there's nothing to distribute out front. Now I need to collect like terms. 6x minus x is 5x. 5x minus 4 equals 31. Add 4 to both sides. 5x equals 31 plus 4, which is 35. Divide both sides by 5. X equals 7. 35 divided by 5 is 7. So if x is 7, I'm going to go plug it in to solve for y. Y equals 6 times 7 minus 4. 6 times 7 minus 4 is 38. Okay, I found my two numbers. Y is 38, x is 7. The smaller number is 7. The larger number is 38.